All right.
Yes.
So modeling and optimization. So one of the things that calculus gets used for is if you can model something mathematically. In other words, if you can write an equation for it, then like in statistics where you do a regression equation, that's a mathematical model. I'm talking to this half of the room at the moment. That's a mathematical model for it. We may want to be able to figure out what is the maximum of something or what is the minimum. In economics, you want to find what is the maximum profit, what is the minimum cost for something. You know, those kinds of things are something that calculus gets used for. All right, so here is the basic strategy, and I went ahead and wrote this whole thing out. So the hardest part most of the time is writing the model and the secondary equation if you need one. Frequently, that's where most of the work happens. Okay, it's a little bit like related rates where, you know, most of the work happened before you took the derivative, right? It's like once you hit and took the derivative, it was all downhill from there. Okay, so a lot of times you're going to have to draw a diagram. Remember, when you draw diagrams, if something changes, then it should have a variable. If something is constant, you can put the constant on it. Okay, and sometimes you're going to need a secondary equation. I'll show you some examples of that. Then identify the critical points and any endpoints. In most of these problems, they're open intervals, or they're squidgy closed intervals, and we'll talk about what I mean by that in a minute. They're like, well, okay, you could kind of call it that. You'll see what I mean. And then solve the model. So if you have a closed interval, you can use the candidates test. If you have an open interval, you can use the lone candidate test if you have just one critical point. Or you can analyze, you know, is this a local maximum, is this a local minimum, all those kinds of things. Okay? And then in the end, answer the question. You'd be surprised how many people at the end of the problem, they have done all this lovely work and they never actually answer the question. Okay? Sometimes it'll ask you, what is the greatest area? And you have to go back in and take what you have figured out will make the greatest area and find the greatest area. Or sometimes it'll say, what are the dimensions that make the greatest area? Then you have to give the dimensions. Be sure that you answer the question at the end. All right. Well, that was page 1. Page 2. What is the largest possible area for a rectangle whose diagonal is 12 inches long, and what are its dimensions? Now, this is one where in the end, you're not going to be at all surprised by this if you know anything about shapes.
What?
So, I'm going to draw a rectangle. Am I drawing a diagonal? One of the most mispronounced geometry words ever.
Diagonal?
It's diagonal. It's 4 syllables, not 3.
Diagonal.
Yes.
It says diagonal.
Most people say diagonal.
Give me this diagonal. Diagonal? Diagonal. Dingle.
Okay, stop. You
You make it 2 syllables.
you're hurting me.
In the middle of the night, he goes, you know what?
It's like when people say straight line, there's a part of me that just like, All right, and we could call this base and height, or we can call it x and y. It really doesn't matter a whole lot. We want to maximize the area, so we need an equation for the area. Well, the area is equal to x times y. We would very much, unlike related rates, where we didn't mind if we had multiple different variables on one side, we'd like this to all be down to a single variable. Okay? And that's where secondary equations come in. So for example, on this one, since I know that this is a right angle, my secondary equation is that x squared plus y squared is equal to 144.
Yeah.
Pardon? So since I want the dimensions, there's really no reason why I should solve for x or y. It doesn't make any difference. One or the other is fine. I'm going to say that y is equal to the square root of 144 minus x squared. So now I'll have the area all in terms of x. It's going to be x times 144 minus x squared to the 1/2 power. Now, the question becomes, is this a closed interval or an open interval? And this is what I was talking about kind of squidgy closed intervals. So what is the smallest that x could be?
No.
It can't be 0.5?
0.
Less.
Can it be equal to 0?
No, it has to be
Zero.
greater than 0.
And so that's where the squidgy part comes in. It's like,
Here's the line.
yeah,
0.0.
it gets really close to 0. Can we consider it a closed interval? Not really.
Bro, that's a skinny.
Okay, what's the biggest that x could be?
Well, no. There you go. There's a problem.
Yeah, just under 12, right?
Yeah.
Anything less than 12. So 0 is less than x is less than 12. I don't always do that. I'll be completely honest. A lot of times I'm like, I just think about it as I go by. But it's not a bad idea to write the domain. So now we'll take the derivative, a prime of x, and that'll be x times 1/2 of 144 minus x squared to the negative 1/2 times negative 2x plus 144 minus x squared to the 1/2 power times 1. For critical points, I'd like to figure out where that's equal to 0. I don't spend a lot of time cleaning these. I will spend a little bit of time. If you were having to do it by hand, then I would also factor. You know, we should probably practice doing at least one of them by hand.
I was like, is he going to do it?
So the 2 and the 1/2 multiply together to be 1. And I'm going to factor out, remember you factor out the lowest common factor. So that'll be 144 minus x squared to the negative 1/2. When I factor that out, all I'll be left with here will be a negative x squared. And when I factor that out of this one, I'll be left with, if I factor something to the negative 1/2 out of something, that same something to the positive 1/2, what am I left with?
0.
1/2 minus negative 1/2 being
1.
1.
2 to 1 is.
So I'm going to have plus 144 minus x squared. So this is going to be a negative 2x squared plus 144 over the square root of 144 minus x squared. Notice that that doesn't exist if x is equal to 12, but we excluded that from our domain, so we don't have to worry about that. If this is equal to 0, the numerator just has to be 0. So that would give us 2x squared is equal to 144. So x squared is 72. So x is the square root of 72, or if you like to rationalize things, 6 square roots of 2. You're good with the square root of 72, and that's fine.
It looks a lot better.
It does look bad. How'd you do that so fast?
With his brain.
Oh, okay. That
I
makes
teach geometry. I'm pretty good at taking square roots.
Lily apparently is not.
No, how'd you? Okay. I know you did it.
How'd I what?
It was just really speedy. I'm impressed.
Oh, thanks.
You're welcome.
I was thinking ahead.
Oh.
So x would be the square root of 72, and then we can figure out what y would be using our secondary equation. So if it was the square root of 72 squared, that's going to be 72 plus y squared is equal to 144. So y is going to be the square root of 72 also. So it's the square root of 72 inches by the square root of 72 inches. That x is not meant to construe x or multiplication, but dimension.
Yeah.
So what kind of a thing is this?
A square.
It's a square. Is that surprising?
No.
No. A long, thin rectangle would have less area.
I don't know.
It's right there.
It's your wallet.
Literally right there.
Why are you making old man noises?
Because I'm an old man.
Okay. All right. Let's try this one. A rectangle is to be inscribed under one arch of the sine curve. Okay.
It's your shammy short.
What is the largest area the rectangle can have?
Sine.
Well, so we should probably draw the sine curve, or at least one arch of it.
Mark.
Isn't that just a hump?
A hump? Yes.
Okay.
Hump day.
That was such an odd shared experience.
Yes, one days. That's calm.
That's pretty awful.
Make it into a camel. Today's picture.
I can't even draw the hump. How am I going to draw a
Do your
camel?
best.
So the rectangle would look something like that. So we're trying to figure out what makes the area as large as possible. Now, generally speaking, area for a rectangle, base times height, right? So we need to get base and height both in terms of some same variable. Okay? So what I'm going to do is I'm going to arbitrarily decide to call this point x.
Okay.
Then the coordinates of this point would be x sine of x. And what would the x coordinate for this point be?
Pi minus x.
Indeed it would be. Nicely done. It's pi minus x. Because this is going to be x away from pi, just like this is x away from 0, because of the symmetry. So my base is going to be pi minus x, right? So that's pi minus 2x. What will the height be?
Sine x.
Sine of x. So now I can rewrite this as the area in terms of the variable x. So that will be, the base is pi minus 2x times sine of x. Let's talk about the domain. So what?
Did you hear that?
Yeah.
Hear what?
No, you went Queen of England on us for a second.
Yeah.
Oh, I did say domain. Yes,
Domain.
it happens now and then.
It
Slips
slips.
up.
He's actually a spy for the British government.
Okay.
I have no response to that.
He
I
was
could
really
I could
shocked
tell
that
you,
you
but I'd
screwed
have
it
to
up.
kill you.
Oh, okay.
So what x values are we allowed in this? 0 to pi. On this, could you make a case for saying I could go for all the way from 0 to pi?
Yeah.
Like, yeah.
Yeah, it's just that you would have a minimum at the ends, wouldn't you?
Yeah.
But we could do this as a closed interval then. So then taking the derivative, let's see, we'll have pi minus 2x times cosine of x plus sine of x times negative 2. As soon as you have an x cosine x or an x sine x, you're never going to be able to do that by hand. Yeah, I know. You're greatly saddened by that. So let's clear that out and put in the derivative. So pi minus 2x. Oops. Apparently pi minus 2x cosine of x. Be sure to close the parenthesis at cosine. You know, a lot of times when you're doing cosine with numbers, you don't bother, but it really will mess things up if you don't here. Minus 2 times sine of x. And I'm on a window from 0 to pi.
Oh, I had really awkward eye contact with that man.
Why is he like looking at there?
I'm holding it.
I guess we could all look back, but
Well, one of them's my mom.
Really?
Yeah.
Yeah, she definitely looks like you. I actually think it's the guy with the black shirt and jeans is your mom.
That was terrifying.
Yeah, he was like, I wonder what they're doing in there.
All of us are just.
Yeah, the worst part is we're all staring back at him.
You want some staples?
did I graph that correctly?
I got different.
Shouldn't it
I got different.
be?
I think it's a line, but
Oh, you didn't?
Pi minus 2x cosine x.
this should be
What's
weird.
sine of x?
Shouldn't it be negative?
Yeah, we're
cosine?
doing
Oh, you multiplied the 2 in the wrong place.
Yeah. Oh, now it's kind of. Yeah, I think.
I don't think that's a.
Oh, it's supposed to be minus not.
Yeah, mine.
There we go. That should look better.
Not even really careful.
No, I'm good.
It's like the MI6.
You already have a satanic.
That's actually a Teletubby game.
So now we'll find the 0, somewhere between 0 and 1. So x is equal to 0.710, yada, yada, yada. There's another one, but notice the symmetry. If it's over here, all that's going to happen is the rectangle is going to switch sides, right? It's going to be the same area. So what happens to the area at 0 or at pi?
Big 0.
It's 0. So all I need to do is find the area at this point. And it says, what is the largest area? So I just need to substitute that into my original. again, so that I don't have to type all that, I can just type my original with x in it. So that it's pi minus 2x times sine of x. Because it's still thinking that one value of x. So the area is 1.122. By the way, a favorite on the AP exam is actually ones where you have an upper curve and then you have a lower curve. So you have to subtract to find the height. The upper one minus the lower one. All right. Hello. Man, the wheat struck men are just killing me today.
Okay, okay. What's the appropriate? They're smart kids. Okay, smart kids and smart, older than I am gentlemen. So, what do I say to that? So.
That's all right. We were talking about masks earlier, and I said, for myself, I don't really care. And Ian goes, "Yeah, I don't care at all either." And I'm like, "You don't care about me?" All right.
He's like, "Don't make me answer that, Mr. Davis."
So, here is a problem that's in pretty much every math textbook since people have been making boxes. I'm not kidding. Yeah. So an open top box is to be made by cutting congruent squares from the corners of a 20 by 25 inch sheet of tin. And then you just fold up little flaps and seam them together and you have an open top box.
Yeah.
Okay?
Yeah. Just for fun.
Well, they
That's
want
actually
to...
what Ian does in his free time.
It's actually a very easy way to make a box. Lid.
And you want to see what's the maximum volume you can make out of this box.
Well, why?
Okay? So
Make it square.
the volume for a box, actually no. Thank you for playing. We have some lovely party gifts for you.
Yeah, because you're going to cut out more.
So volume for a rectangular solid, length times width times height.
Whatever you say.
I think we should make a sphere.
All right, and we need to get all of those in terms of a single variable. Well, notice what varies here is how much I'm going to cut off. So let's call the length of the piece that I cut off C. You can call it Bob for all I care.
C is for cut.
So then the length would be equal to how much in terms of C?
25 minus 2C.
Yeah, 25 minus 2C.
And your W,
And then the width would be
20 minus 2C.
20 minus 2C,
The height is C.
and the height is C.
C is for kids.
So the volume in terms of C
25 minus
is 25 minus 2C times 20 minus 2C times C. And what are our restrictions on this? Well,
greater than 0.
it's got to be greater than 0 or we're not going to have a box, right?
Less than 20. Or no, less than 10.
Yep, and less than 10. And I guess let's make that an open interval. Because if you don't cut any, you don't get a box.
Yeah, cut all of it, and you have a sheet. That is folded.
So then you could use the product rule with this, but wouldn't it be a lot easier just to expand it and then take the derivative?
Yeah.
Yes, please.
Okay,
Yeah.
so that's going to be 500 minus 40 minus 90C
Sounds about right.
plus 4C squared all times C,
I see.
said the blind man to his deaf wife as he picked up his hammer and saw. and then distributing the C.
And sometimes when the planets align just correctly, Mr. Davis and Maddie get on the exact same brainwave and tell me the exact same thing.
Brainwave.
My dad tells that joke all the time. I see, says the blind man as he picks up his hammer and saw.
And then there's a whole other part about that with his. I don't remember what it is. There's a whole bunch of other part, and I'm like, okay.
Minus 180C plus 12C squared.
And we want that to be equal to 0, and that's a nice polynomial function.
Just
I'm
a
calling
nice
him your function.
polynomial.
Look, if you get to be British.
Gotcha. And in the interest of time, let's just use a calculator to figure out what those are. 500 minus 180C plus 12C squared. And for my window, I'm going to go from 0 to 10. And graph. Wow, that went through in a hurry. Zing!
Speedster. It's like 3.5, maybe 3.7.
Yeah, more than 3.
I think 3.7 is my guess.
Okay.
6, 8.
3.75.
I'm gonna guess 3.8.
3.6.
3 point. You're wrong.
Oh, hang on a second. I actually hit enter too many times.
Rookie mistake.
I'm actually no, 3.73.
Everybody have their guesses locked in?
Yeah.
73.
3.75.
0.73.
What?
3.68.
I was the closest.
No, you
No, you
didn't.
weren't.
I said 3.7.
And then you.
I said 3.6.
7.3. 6.5 is still farther away than.
No, I said 3.68.
Let me say 3.6811.
That's why he said, does everybody have their guesses locked in so that nobody can pull you and change it in the last
No,
minute?
your locked-in guess was 3.73.
So- Now notice on this one, it wants what is the greatest volume. So we need to substitute this back in and find the volume.
No.
Such enthusiasm.
There you go.
And money.
So 500 times the x value minus 180 times the x value squared
It's 90.
plus 4 times the x value cubed.
It's not 180, it's 90.
Yeah.
Yeah.
Oh, sorry. Thank you.
That's much better.
Yeah.
Yeah.
The maximum volume is negative, and I'm like, uh-oh, we have folded this into the 5th dimension. Remember, 3 decimal places minimum? Was it centimeters?
Inches.
Yeah.
Inches.
Cubic inches.
We're American.
Ew. Don't like
All right, last one. Find the dimensions of a cylindrical can holding 1 liter
It's
that uses the least material. So we want a can that holds a liter. Okay, so we're talking about volume, right?
yeah.
But we want the least material. So if you're building a can, the material is made up of what parts?
Sides. And
Okay,
top.
so the sides,
So all of it.
how can you find,
Circumference times the height.
right, so 2 times pi times the radius times the height,
Yep.
plus what else?
The area times 2.
The area of what?
The top.
The circle.
The area of the 2 bases, so 2 pi r squared. We'd like to get this down to a single variable. and we're given the volume. It's 1 liter. Well, what is that in terms of cubic somethings? Uh-oh.
I don't know.
Centimeters cubed.
Grams.
Grams. Oh, gosh.
Isn't a milliliter a centimeter cubed?
Yeah.
Yeah.
So,
1,000
Meter
centimeters cubed.
yes, 1,000 cubic centimeters.
Wow.
So the 1,000 cubic centimeters is going to be the volume. And what's the formula for the volume for a cylinder?
Area.
Yeah, so that's pi r squared times h. So in looking at these two equations, I want to get m all in terms of a single variable. What do you think I should solve for in this one? Should I get r by itself or h by itself?
Always 1H.
Yeah, I would get h by itself, partly because of the square root that you would have to do to get r by itself.
Yeah.
That, and then you would also have to substitute that in 2 different places over here.
That's hard. That's hard.
So I would do 1,000 over pi r squared is the height. So the amount of material is going to be 2 pi times the radius times 1,000 over pi r squared plus 2 pi r squared. I would certainly try and simplify that before. Oh, we didn't talk about the domain for this.
H has to be greater than 0.
Well, since I have all r, that would be more important to know.
R has to be greater than 0.
Yeah.
Um,
And is there any limitation?
no.
Nope. R just needs to be positive.
It's a big can.
Well, it could
Yeah,
be like
well,
a-
if it was going to hold a liter and it, and R was 5 miles, then it would have to be like
little baby straw.
1/10 of a millimeter tall.
It's a straw.
A straw?
Mhm.
Not if the R was enormous.
Oh,
Because then it would be this
yeah.
It would be a disc.
It would be a
with H.
Oh.
ring.
That's a UFO. That's a UFO full of Diet Coke.
Big circle.
All right, so
Diet Coke.
this would be
Or HEB Coke. No.
2,000 R to the negative 1. Did I do that right?
Yeah.
Yeah.
Plus 2 pi r squared. So now I'll go ahead and take the derivative. dm dr.
Good.
They're open now.
It's negative 2,000 r to the negative 2 plus 4 pi r. I want that to be equal to 0. So 4 pi r is equal to 2,000 over r squared. So r cubed is going to be 2,000 over 4 pi, which is 500 over pi. So the radius would be the cube root of 500 over pi. And you'd probably grab a calculator to give a decimal approximation for that. So 500 divided by pi raised to the 1/3 power.
Would you quickly go, what is it? Approximate.
5.419.
5 point. Oh, wow. That's what I was gonna say.
That's what I was thinking too.
Really?
Yeah.
you're thinking of something dumb like 5.3.
And then we want to find the height as well because it asks for the dimensions.
Oh my gosh.
Well, fortunately, we have an equation for that.
Hard.
Yeah, you
One
just
thousand
plug it
But you have to plug it all
over
in.
pi
But
times.
you have this value already in there, so you don't have to retype it. It's just going to be 1,000
Fine, I love math.
divided by
That's 100.
pi times my previous answer squared.
1.083.
What do you notice about that?
It's close to 1.
Oh, sorry, 1,000, not 100. I did that earlier today.
10.838.
10.838?
It's like we went
It's-
to fifth grade math.
It's 5.419 times 2.
Yes, it is. So the diameter of the can and the height of the can are equal to each other.
Oh, wow.
So it's like a little square can.
I went to the UFL one.
It's sort of a what? It's sort of a cube that you have shaved all the corners off of.
Yeah.
They're wasting money on material for aluminum cans.
It should just be a square.
Square can would have been cooler.
And actually, we used to do this one. You have to do a lot of conversions. It used to be that oil was sold by the quart in a cylindrical can, and you could actually figure out what the least amount of material you can make, and it was almost exactly the size of the cans that everyone who sold oil sold them in.
Whoa.
They're so smart.
Well, someone took the time to figure out what would cost the least.
To be fair, it took like.
Not that long.
Yeah.
Yeah.
They just had to sit there and do that.
It took like, maybe 5 or 10 minutes, and it saves them
Save money.
thousands of dollars.
Kind of cool.
Or someone guy to be like, I took calculus actually, so I can.
Yeah. And then you can make it more complicated by saying that the material you make, for the top and the bottom cost a different amount than the sides, and because it used to be that the top and the bottom were metal, and the sides were like a heavy cardboard.
Does that cost more?
Dumb.
Well, before you could make plastics cheaply, it was probably a lot more.